Good day. Today in this lab, we'll explain the Enterobacteriaceae family, how to identify this bacteria in a lab. As this family is a group of the gram-negative bacteria and include many medically important species such as E. coli, Klebsiella, Salmonella, Shigella, Proteus, and others. We'll focus on a specific culture media used for identifying and differentiate these clinically significant gram-negative bacteria. We can identify this family of the bacteria in lab by colony morphology and biochemical tests. The biochemical tests include carbohydrate fermentation, motility test, MVIC test, urease production, hydrogen sulfide production, trouble sugar iron, and we first observe how the bacteria grow in a culture media, then confirm the identify using biochemical reaction. Most common culture media used for Enterobacteriaceae are Eosin methylene blue, Salmonella, Shigella agar, Macongi agar. All these media selective and differential. Selective, it means inhibit certain bacteria, allowing other to grow on it, and differential, it means differentiate between the species of the bacteria according to the biochemical characteristic and usually lactose fermentation. Now, the Eosin methylene blue agar is selective and differential for Enterobacteriaceae gram-negative bacteria. It's selective for gram-negative bacteria because it contains the dyes eosin and methylene blue, and this dye inhibit growth of the gram-positive bacteria, allowing growth of the gram-negative bacteria. Why it is differential? Because it contains the lactose, which can differentiate between the lactose fermenter from the non-lactose fermenter bacteria. And this media is important for identifying the Escherichia coli. In this image, you can see the growth of the E. coli on this type of the agar that lead to produce dark blue-black colony with a metallic green shine. And this metallic shine is important for identification of the E. coli. Why this character is mostly specific for the E. coli? As I mentioned, it's a selective for gram-negative bacteria. It allows gram-negative bacteria to grow on it. And it contains the dyes eosin and methylene blue. E. coli, when grow on this type of the media, it lead to the fermentation of the lactose and to produce large amount of the acidity. This large amount of the acidity, it react with this dye and lead to the color change, which produce the dark blue-black column with a metallic green shine. Other gram-negative bacteria, such as those that are non-lactose fermenter, will lead to the colorless when grown in this type of the media, while the Klebsiella that are also ferment the lactose, why don't produce the metallic green shine? Because it ferment the lactose while produce small amount of the acidity, and this small amount of the acidity when react with this dye lead to the pink color, not black blue colony with a metallic green shine, which is a specific characteristic of the E. coli. So both of them, E. coli and Klebsiella, is a lactose fermenter, but the E. coli is a strong lactose fermenter and lead to the production large quantity of the acidity. This acidity react with a dye and lead to the blue-black colony with a metallic green shine. Another selective and differential media, Salmonella, Shigella agar, which is mainly used for stool culture. For identification, Salmonella and Shigella is selective as it inhibits growth of the gram-positive, allowing growth of the gram-negative. Differential, it contains the lactose. It can differentiate the lactose fermenter from the non-lactose fermenter bacteria. In this type of media, we can also detect the production of the hydrogen sulfide, which can detect as a black center. Salmonella and Shigella, when grown on this type of media, produce the colorless colony because it's not fermenter bacteria. But Salmonella produce colorless colony with a black center, while Shigella without a black center. Why? Because Salmonella release the hydrogen sulfide, while Shigella without hydrogen sulfide. The coliform colony, like the E. coli colony, appear as a pink or red color because it's lactose fermenter bacteria. But this type of the bacteria, they are non-release hydrogen sulfide. So the colony of this bacteria without a black center. And in this image, you can show the difference between the colony of the gram-negative Enterobacteriaceae on this type of the media, Salmonella, Shigella, agar. E. coli can grow on this type of the media because it's selected for gram-negative, produce the red to pink colony because it's lactose fermenter bacteria without black center. Salmonella produce the colorless colony because it's not lactose fermenter but with black center due to the release of the hydrogen sulfide. Shigella produce colorless colony without black center because they are non-lactose fermenter and not release the hydrogen sulfide. Another important selective and differential media for gram-negative Enterobacteriaceae, Macongi agar. This type of the media is selective because it contains bile salt and crystal violet that inhibit the growth of the gram-positive and allowing only the growth of the gram-negative like Enterobacteriaceae. Why it's differential? Because it contains the lactose and neutral red indicator. This type of the media, we can differentiate between the lactose fermenter bacteria from the non-lactose fermenter bacteria. As the lactose fermenter bacteria like E. coli, Klebsiella, and Enterobacter, when grown on this type of the media, it leads to the fermentation of the lactose and change the color of the indicator neutral red and produce the pink colony. While the non-lactose fermenter bacteria like Salmonella, Shigella, Proteus produce the colorless colony because it not ferment the lactose in the media and not change the color of the indicator. As I mentioned, Macongi agar is important selective media for gram-negative bacteria as it contains bile salt and crystal violet that inhibit the growth of the gram-positive, allowing the growth of the gram-negative bacteria. I mentioned it contains the bile salt and the crystal violet, and this inhibitor substance inhibits the growth of the gram-positive bacteria, allowing the growth of the gram-negative bacteria like Enterobacteriaceae. It's differential, it contains the lactose, it can differentiate between the lactose fermenter bacteria from the non-lactose fermenter. The lactose fermenting bacteria appear as a pink colony due to the fermentation of the lactose, produce the acidity and change the color of the indicator, while the non-lactose fermenter bacteria, it appear as a colorless colony. In Macongi agar, we can differentiate between the species of the gram-negative bacteria by the ability to ferment the lactose. The lactose fermenter bacteria like E. coli and Klebsiella produce acid during lactose fermentation, and this acidity lowers the pH of the media. This acid reacts with the neutral red indicator and make the colony appear red or pink, and often surrounded by zone of the precipitate bile. In the other hand, lactose fermenter bacteria like Salmonella and Shigella it not produce the acid because it's not lactose fermenter, and the colony remain colorless and the media around them is no change. This allows to differentiate between the lactose fermenter from the non-lactose fermenter on this type of media. In this image, you can see the difference between the lactose fermenter bacteria from the non-lactose fermenter bacteria. Non-lactose fermenter bacteria produce colorless colony, while the lactose fermenter bacteria produce the pink colony. Now, we can more differentiate between the lactose fermenter by observe the texture, the colony morphology on Macongi agar. Here you can see the colony of the E. coli and the Klebsiella. We can differentiate between them, as both of them produce a pink colony on Macongi because both of them is a lactose fermenter. But the E. coli characterized by a dark pink colony, while Klebsiella characterized by mucoid pink colony as a result of the capsule production. Due to the capsule production, it have mucoid colony, while E. coli have a dry pink colony. And here you can observe the colony of the E. coli and Salmonella enterica. E. coli have a pink red colony, while the Salmonella is colorless colony because E. coli ferment the lactose, while Salmonella, they are non-ferment the lactose that lead to the colorless colony.